Lesson 5 examples. Let's talk about the definition of an exponent. When you have x to the n, the x is called the base, and the n is called the exponent. Now, depending on that value of n, all it's telling you is you're multiplying that base that number of times. So x to the third would be x times x times x. We have to watch our rules for sign numbers when we're doing exponents. So we'll do that as we go through these examples. Negative 3 to the third means negative 3 times negative 3 times negative 3. That's going to be a positive 9 times a negative 3, so we get negative 27. When you have an odd number of negatives, you're going to get a negative result. Now, you can do these on your calculator. You do have to enter the parentheses, use the caret key, and then enter your exponent, and then hit enter, and it will calculate it for you. If you don't put the parentheses, you could miss some of these. In this case, since it has an odd exponent, it won't matter so much. But if we had had the second one, negative 7 to the second, means negative 7 times negative 7. That's a positive 49. If you leave the parentheses off and you write it like this, or do it like this in your calculator, you're going to get negative 49. So you need to be really careful. If the problem shows parentheses, you need to write the parentheses in your work and also in the calculator. Question number 2. It also says to evaluate the opposite of 7 squared. That means a negative and a 7 times 7, which is also negative 49. Now, if you over apply that exponent, you will miss this one. Look at the location of the parentheses. The sign is on the outside. If the sign is on the outside, the exponent doesn't apply. And in fact, if you have a base without parentheses, such as minus 7 squared, that also means 1 minus and 2 sevens. The exponent only applies to what is right in front of it, unless there are parentheses, in which case it applies to the whole thing. The opposite of 7 squared will be a negative 49, and this one is negative 7 squared, which is a positive 49. Now I have, in the second part of question 2, the opposite of negative 2 cubed. Now, in reality, this is 4 minus signs, which is going to make a positive, because an even number is going to be positive. Where do those come from? Well, this initial one, and then 3 more. These two will match up to make positive. These two will match up to be positive. So this answer is going to be positive 8. Now, we're not just automatically matching them up here. What we're doing is we're writing it all out to get the correct answer. And you can do that in your calculator. You can type in the minus sign, not the subtraction, but the actual negative, and then parentheses, the minus sign 2, close your parentheses, caret key 3, and then enter. And it should give you a positive 8. If not, you've left off something. Now we have some fractions, and that's okay. It's going to work the same way. 5 cubed over 2. You want to make sure you don't over apply your exponent. That only goes to the 5, so that's 125 over 2. 5 to the third is 125 because it's 5 times 5 times 5. 25 times 5 is 125. And again, you can do that on your calculator using this caret key. The second part of number 3, the opposite of 5 over 4 squared, the exponent applies to the top and the bottom of this fraction, but not this minus sign. So it's minus 5 over 4 times 5 over 4. So that minus is going to stay a negative. There's nothing to pair it with to make it positive. 25 over 16. Now let's talk about the rules for exponents with operations. So rules for operations with exponents. And these are going to be the rules for multiplying and dividing. The rules for adding and subtracting are just the rules for like terms, okay? So we'll do a couple of those a little bit later, but let's talk about multiplying and dividing. Rule number 1, the product, that means multiplication, of like bases, that means they're the same. That would be like x to the second times x to the fifth. We have two bases that are alike. Their exponents are different, but the bases are alike. That means there are 2x's multiplied times 5x's. And if you count the total of those, you'll see that is x to the 7th. So the rule says x to the m times x to the n is x to the m plus n. That when you multiply like bases, you add your exponents. Now, if those expressions happen to have coefficients like number 4, that'll need another rule, which we'll call product of like bases with coefficients not equal to 1. So up here I had a 1 and a 1. Now we're going to look at some with coefficients that are not 1. So a b to the m times c b to the n. Now notice the bases, that is the part that's raised to a power, are still the same. We just do a times c b to the m plus n. So in other words, coefficient times coefficient, I'm going to abbreviate that just for brevity's sakes, and then base with the exponents added. Now that will help us do question number 4. So here's question number 4. Negative 3v to the 8th, parentheses mean to multiply, times negative 9v. So I'm going to multiply negative 3 times negative 9, and it's going to be v to the 8 plus 1, because there's a 1 understood exponent there. That's going to give me 27v to the 9th. Now in question number 5, 3x to the 7th times 7w times 2w to the 3rd times x to the 5th. And notice they didn't write the dot here. Anytime two variables are beside each other with nothing between, it means to multiply. So you don't have to have the dot. Well, in this case, we're going to use the exponent rule plus a property called commutative. The commutative property of multiplication says a times b is b times a, or a times b times c is b times a times c, in any order you want to put them. So what I'm going to do is I'm going to slightly rearrange this. 3x to the 7th times x to the 5th times 7w times 2w to the 3rd. So you can do this part in your head, the part where you are saying the x's can be multiplied by the x's and the w's can be multiplied by the w's. But it's nice to see that you can rearrange it according to the commutative property. And now all I have to do is multiply the coefficients, and I don't add the exponents this time because the bases are not alike. Remember the rule said for like bases, like these w's up here, we added and got 4, and these x's we added and got 12. And 3 times 14 is 42. So there's my answer for number 5. Now for number 6, we're going to need the third rule for exponents, and that is the division of like bases, x to the m over x to the n, okay? Now this is one of 3 cases. Case 1, m greater than n, big exponent on top. Case 2, m less than n, that's the big exponent on bottom. And case 3 is m equal to n, so the exponents are identical. So the one that they gave us is case 2, but let's look at an example of case 1. I'm just going to reverse 12y to the 5th over 16y to the 2nd. So I'm doing case 1, and instead of doing our exact problem, I flipped it over so that the biggest exponent's on the top. Okay? What the rule says is that in case 1, you just subtract the exponents, m minus n. And any fractions you have, you reduce. So 4 will go into both of those, so that's going to reduce to 3/4. And when I do my exponents, I do it in the numerator, and I get 3 over 4 y to the 3rd. Because the larger exponent's in the top, the exponent and the base end up in the top. Now, case 2 is the one that we have in our example for lesson 5, and that is 16y to the 2nd over 12y to the 5th. And that's going to give me a 4 over 3, and my y to the 3rd is going to be in the bottom. And the reason for that is this is 1 over x to the m minus n. And just think of it this way. If you have more y's in the denominator, you're going to have y's in your denominator in your answer, and you're still going to subtract 5 minus 2. And then let me go ahead and do a case 3 where they're equal. X to the 3 over x to the 3. Well, you can subtract those, but 3 minus 3 is 0, and anything to the 0 is 1. So in case 3, the answer is 1. Unless you have coefficients like 12x to the 3rd over 16x to the 3rd. Well, that's going to be 3 over 4 times 1, which is 3 over 4. And you can think of it this way. Those divide each other out to 1. It's the same thing. Any number divided by itself is 1, and that is why this is the case. That when you have like bases or a 0 exponent, you're just dividing a number by itself, and the answer is 1. So that was our third rule of exponents. Now let's go to our fourth rule of exponents. It says when you have a base to a power raised to another power, you multiply the exponents. Let's see why. Let's say, well, we'll do the one that's on the lesson, x to the 3rd to the 5th. This means 3x's. This means 3x's 5 times. So let's see. X times x times x, that's 3x's 1 time. X times x times x, that's 3x's 2 times. X times x times x, that's 3x's 3 times. X times x times x, that's 4 times. And x times x times x is 5 times. So look, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It would have been a lot easier just to multiply those exponents. According to the rule, power to a power, you multiply the exponents. Here's why. But of course, the larger these numbers are, the less likely it is that you're going to want to write this out and figure out how to do it. So you need to memorize. Power to a power, we multiply. Now, our fifth rule of exponents says that when you have a product to a power, that's a couple of things multiplied. This is called product to power. And that can be a coefficient instead of like an x or a y. It can be a number there. In either case, everything in the parentheses is raised to the power. So look, this m is multiplied times this 1. This m is multiplied times this 1. Same thing here. These are 1s, and you're doing the rule 4, but you got to remember to do it to both parts. So when you have one like number 8 on our worksheet, 3u squared, we have two options, 3u times 3u, or 3 squared times u squared, 9u squared. And in a lot of these cases, you can do some of these steps in your head. But here's the steps that you're taking, and until you're very confident with those steps, you probably should just write in the steps. So question number 9, -4, a to the 4th, b, all raised to the 3rd. We don't need any more rules for this because we have all the rules we need. -4 is raised to the 3rd. A to the 4th is raised to the 3rd. And b is raised to the 3rd. So that's -64. You can do that on your calculator. A to the 12th, because power to a power we multiply, b to the 3rd. So that's the answer to number 9 on our worksheet. Outer exponent, product inside, that means multiplication. It's applied to everything. Number 10. Turns out that when you have a quotient to a power, the same rule applies. So like we saw way back in the very beginning when we did a fraction to a power, we have to do the top to the power and we have to do the bottom to the power. I'll do that -2 to the 5th in my calculator, put it in parentheses, okay? It doesn't matter so much since it's an odd exponent, but if it was an even exponent, your calculator would do it wrong. The answer to that's going to be -32 x to the 20 over y to the 5th. Now we see in question number 11 the 0 exponent. We already talked about this a little bit, but let's write this down as rule number 5. Any base to the 0 power is 1, except the base can't be 0. So the opposite of 5 to the 0 is -1. 1/7 to the 0 is +1. Now remember, this 0 does not apply to this sign, so that's why it came over. In this case, the 0 applied to the whole thing, so it's just 1. So number 12, we already have the rules for doing this. It's a little bit of a review. 4x to the 2nd, -3x to the 5th. Coefficients get multiplied together, exponents get added. So it's -12x to the 7th for number 12. And the last one, number 13 on our worksheet, 2y, 8y to the 8th, times v to the 8th, times 2v to the 6th. Well, 2 times 8 times 2, y to the 1 plus 8 v to the 8 plus 6. So I'm adding my exponents, and I'm multiplying my coefficients. So that's 32 y to the 9th, v to the 14th.